Well, welcome back to our discussion about using the sum and difference formulas to evaluate trigonometric functions. And in this video, we're going to continue with some more examples on using these formulas to find exact values of trig functions. So we are going to look at a couple of things here. One will be similar examples to what we did before, except we'll be using radian measures. So this is the same exact process. We are going to go a little bit quicker since we've looked at some examples before. We are going to examine these examples and say, okay, well, this is the sign of a sum. So we'll look at the sum formula for sine, and then we'll identify our alpha and beta. Alpha is 4 pi over 3, and beta is pi over 4. And then we'll sub those things into our formula. So we will have the sine of 4 pi over 3 times the cosine of pi over 4 plus the cosine of 4 pi over 3 times the sine of pi over 4. And then from that point, we will evaluate each of these pieces. What is the sine of 4 pi over 3? Well, that's negative rad 3 over 2. Cosine of pi over 4 is rad 2 over 2. Cosine of 4 pi over 3 is negative 1/2, and sine of pi over 4 is rad 2 over 2. And so when we multiply these things, we end up with negative rad 6 over 4 plus negative rad 2 over 4, which when we combine, we get negative rad 6 minus rad 2 over 4. Always a good idea to check this in your calculator. One thing you can do is just put this expression into your calculator, this numeric expression, making sure that your numerator is put in parentheses so the whole thing is being divided by 4. And then you can evaluate this sign, and you can do it just like this as long as you make sure your calculator is in radian mode and that you've got parentheses around the argument. The other way you could do it then is to actually combine these fractions and get a common denominator and just do it that way. But either way, you want to probably take a minute and double check that what you've done is correct. All right, let's move on to our next example. We have the cosine of a difference. So we're going to come up and grab this cosine formula of a difference. So we'll identify our alpha and beta. Alpha is pi over 3, while beta is pi over 4. And then we will go ahead and substitute these values into our formula. So we'll have the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. And then once we have it like this, we'll go ahead and evaluate each piece. So the cosine of pi over 3, that's going to be 1/2. The cosine of pi over 4 is square root of 2 over 2. Plus the sine of pi over 3 is rad 3 over 2. And the sine of pi over 4 is rad 2 over 2. So we end up with the square root of 2 over 4 plus the square root of 6 over 4. We'll go ahead and express this as a single fraction. Okay, so next, let's do tangent because tangent's everybody's favorite. We have a tangent of a sum, and so we will use this formula over here. Our alpha will be 2 pi over 3, while our beta will be pi over 6. We'll go ahead and replace our alpha and beta in our formulas. So both of these alpha expressions will be replaced with 2 pi over 3, and both of these beta expressions will be replaced with pi over 6. Okay, so now we can replace both of the tangent of 2 pi over 3 with negative rad 3, and both of the tangent of pi over 6 with square root of 3 over 3. Okay. So now let's look at what we have here. Okay, in the numerator, we're definitely going to want to combine these into a single fraction, but in the denominator, take a look at what's going to happen. If I multiply this negative square root of 3 times this positive square root of 3, all I have is to have negative 3 in the numerator. So I'll have negative 3 over 3, which will be negative 1. But I have this negative out in front of that whole thing. So I'll end up with 1 minus a negative 1. Now notice to make this negative rad 3 in the numerator have a common denominator, we just multiply the numerator and the denominator by 3 and got negative 3 rad 3 over 3. And so now as I go ahead and crunch this together, I've got negative 3 rad 3 over 3 plus 1 rad 3 over 3. So I'll get a negative 2 rad 3 over 3 in the top. And this 1 minus a negative 1 on the bottom will become just 2. Okay, so now think about what we're doing here. I'm taking negative 2 rad 3 over 3 and dividing it by 2. Well, I'm taking 2 of something and dividing it by 2. We're going to end up with just negative rad 3 over 3 in this case. Well, that kind of makes sense because if I think about what am I really evaluating here, I have 2 pi over 3 plus pi over 6. That's really 4 pi over 6 plus pi over 6, which is 5 pi over 6. And we know the tangent of 5 pi over 6 is negative rad 3 over 3. Okay, so we're going to move on into something similar but a little bit different here. In this next example, we are going to look at a couple of different things. One, I condensed my formulas into something that's going to take a little bit less space. And notice that what I've done here is I've just made these plus or minuses, okay? So that means that if I'm doing a sum, I'm going to take the top sign. So over here I would take the plus. If I'm doing a sum here, I take this top sign, which is going to be a minus. If I'm doing a sum, I'm going to take the top sign in the numerator, which is plus, but in the denominator, the sign will be negative. That is just going to help us with space. So now, notice that what we're doing is we're going to use a sum or difference formula to evaluate this exactly. Now, we don't know what sine of 165 degrees is. So I want to break this apart into two things, either a sum or a difference of degree measures that I do know. Okay, and so that's why those examples we did before were done, to kind of segue us into this idea. Now, when we do this, it's helpful to kind of look at a unit circle. We do know that 165 degrees is somewhere around here. So I'm going to focus my attention on angle measures that are close to 165 degrees. So let's go right next to 165 degrees on my unit circle. If I'm thinking about 150 degrees, well, I'd have to add 15 degrees to that to get 165, and that I don't know anything about. If I go back, though, to 135 degrees, I could express this as the sum of 135 degrees plus 30 degrees. That would work. Well, what if I go back to 120 degrees? What if I go back to 120 degrees? Oh, I think that works too, because I could express the sine of 165 degrees as the sum of 120 degrees plus 45 degrees. I know both of those. I could also think about it as a difference. If I'm thinking about 210 degrees, that would be subtracting 45 degrees. So I could write this as a difference. So there are a lot of different ways that you can write 165 degrees as a sum or a difference to allow you to evaluate it exactly. And it really depends on your preference. Any one of those should get you the correct answer. So I'm just going to go ahead and choose one. I'm going to go ahead and say that the sine of 165 degrees is the same as the sine of 120 degrees plus 45 degrees. Okay, so now I've expressed this as a sum of a sine. So I'm going to use a sum formula for the sine, which means since the sum is on top here, I'm going to use the top sign, S-I-G-N, here, and I'm going to use sine of alpha, cosine beta, plus cosine alpha sine of beta, where alpha is 120 degrees and beta is 45 degrees. So when I sub those things into my formula, then I can go ahead and evaluate. All right, so the sine of 120 degrees, what is that? The sine of 120 degrees, I think that's rad 3 over 2. And cosine of 45 degrees is rad 2 over 2. While the cosine of 120 degrees is negative 1/2, and the sine of 45 degrees is rad 2 over 2. All right, and then we multiply, so we'd get rad 6 over 4 plus negative rad 2 over 4. We can write this as a single fraction, rad 6 minus rad 2, all divided by 4. All right, so now let's think about this next one. Here it gets a little more challenging because most of you are not quite as adept at thinking about radians or fractions. So let's think about 5 pi over 12. That's really close to 6 pi over 12, which is pi over 2. So I want to think about some angles that are close by to 5 pi over 12. I can think about 5 pi over 12 as being right here. So I want to maybe think about maybe summing some things in here, or perhaps taking one of these and creating a difference. So I can think about 5 pi over 12 being broken into two pieces. I can think about it as 1 pi over 12 plus 4 pi over 12. Oh, but I don't know anything about 1 pi over 12. Well, what about 2 pi over 12 and 3 pi over 12? Well, I don't know much about those, except when I reduce them, they do become things that I do know. Pi over 4 and pi over 6 are definitely things that I know about. The cosine of the sum of pi over 4 plus pi over 6. So I'm thinking about this formula here, the cosine of alpha plus beta. So that's a sum, which means I'm going to take the top sign, which means here I'm going to use the minus. And alpha will be pi over 4, beta will be pi over 6. I'm going to go ahead and sub those into the formula. So I should get cosine of pi over 4 times the cosine of pi over 6 minus the sine of pi over 4 times the sine of pi over 6. When I evaluate those things, I should get square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So when I multiply those things through, I get square root of 6 over 4 minus the square root of 2 over 4. Writing this as a single fraction, we'll get square root of 6 minus square root of 2, all divided by 4. It's always a good idea to check using your calculator. The exact numeric answer is the same as what your calculator gives you for the cosine of this. All right, we've got one more like this. The tangent of pi over 12. All right, so I've got 12ths there. Now, if I'm smart, I'm going to go back and think about this, 3 pi over 12 and 2 pi over 12. I can use a difference there with those two things, right? So I can say that that is the tangent of 3 pi over 12 minus 2 pi over 12, which is the same as the tangent of pi over 4 minus pi over 6. So I'll use the tangent of a difference, which means I'll use those bottom signs, SIGNs, and substitute in alpha is pi over 4 and beta is pi over 6. Okay, so when I do that, I end up with tangent of pi over 4 minus tangent of pi over 6, all divided by 1 plus the tangent of pi over 4 times the tangent of pi over 6. All right, so as I evaluate those things, I know that the tangent of pi over 4 is 1, so I can replace those two expressions, one on the top, one on the bottom, with 1. Tangent of pi over 6 will be the square root of 3 over 3. So let's go ahead and replace those. So I've got 1 minus the square root of 3 over 3. And then on the bottom, I've got 1 plus the square root of 3 over 3. Get some common denominators so I can add them together. Now get rid of the denominators by multiplying both the numerator and the denominator by 3. And then rationalize our denominator by multiplying by 3 minus rad 3. on both top and bottom. So we should end up with 9 minus 6 rad 3 plus 3 all over 9 minus 3. When I simplify this, I end up with 12 minus 6 rad 3 over 6, which is 2 minus rad 3. Okay, we're going to go on and look at one more type of example here. These are a little easier now that we've worked with these formulas a little bit. Here we have some examples where we're given some of the right sides of the formulas, and we're asked to identify what is the formula being used, what's the alpha and the beta in this case, what's the simplified formula, and what's the exact value of the expression. So this is a little bit easier because we're working backwards. When I'm looking at this first example, sine of 25 degrees times the cosine of 5 degrees plus the cosine of 25 degrees times the sine of 5 degrees, I'm looking for a sine cosine plus cosine sine. Okay, and so this is definitely not a tangent of a sum or difference or a cosine of sum or difference. It's definitely going to be a sine of a sum. Okay, we know it's a sum because these signs SIGNS match. So we know that this is going to be the sine of alpha plus beta. And our alpha in this case will be the first angle measure and our beta is the second. So we can say that alpha is 25 degrees and the beta is 5 degrees. So we can say that this is really the sine of 25 degrees plus 5 degrees, which is the sine of 30 degrees. And we know that from our unit circle to be 1/2. All right, so for this next one, we can see that this is a cosine cosine plus sine sine. Well, that looks like a cosine, right? But if I have a plus here in between, that means this is a cosine of a difference. So this is really the cosine of alpha minus beta, where alpha is 7 pi over 12 and beta is pi over 12. So really this is the cosine of 7 pi over 12 minus pi over 12, which we know to be the cosine of 6 pi over 12 or pi over 2. And we know the cosine of pi over 2 is 0. And last we have this example over here where we have a positive sign in the numerator and a negative sign in the denominator. We know this will be tangent, and since we're using these top signs, we'll use a top sign here. So this will be the tangent of alpha plus beta, where alpha is 4 pi over 5 and beta is pi over 5. That means that I'm using these two things as, that means I can express this as the tangent of 4 pi over 5 plus pi over 5, which is the tangent of pi. And we know the tangent of pi to be 0. In the next video, we are going to talk about how can we use sum and difference formulas to verify identities? And I'll see you then.